you ever wondered why mathematicians invented logarithm? Actually, logarithms were one of the greatest inventions in mathematics, and today they are used everywhere, from Google algorithms and AI to earthquakes, finance, and sound measurements. Welcome to episode 1 of my TMUA preparation. In this series, we'll build every concept from scratch and solve TMUA level questions. So, if you're aiming for Imperial, Warwick, UCL, or any university requiring TMUA, you're in the right place. Well, I'm starting with what is logarithm? So, if I ask you what is 2 to the power of 3, it's easy. You know, it's 8. But now, if I change my question and ask you what is 2 to the power of something that will give me 8? In this case, it would look simpler and you can give me the answer. But what if the numbers are a bit more complicated? So there we use the logarithm. So instead of this, I'll be writing log base 2, 8 is equals to 3 to get my power. So a logarithm simply answers one question. To what power must the base be raised to obtain the given number? Think of logarithm as reverse of exponents. Just like reverse of addition is subtraction, multiplication is division, and similarly exponents, they have the reverse, which is logarithm. Now, why were logarithms invented? Well, you can imagine many years ago, like 400, 500 years ago, when there were no calculators, no computers, no mobile, scientists and astronomers had to multiply enormous numbers by hand. So a single calculation could take hours. And that's why around 1614, Scottish mathematician John Napier invented logarithm. And later on, Henry Briggs actually developed the common base 10 logarithm that became widely used. So instead of calculating the typical numbers, they would look up the logarithm tables. Now, the real-life application of logarithm, as I described earlier, is in earthquake magnitude, sound intensity, pH scale in chemistry, population growth, compound interest in finance, computer science algorithms, AI and machine learning, etc. Now, understand some technical aspects. So as I told you, logarithm is the inverse function of exponential function. So we write it like this, log ay, and how we say it, it's log base a. Base can be any number. So log base a y, and that's equals to x. Now understand why the base number cannot be equals to 1 or greater than 0. Understand this part. If I'm writing log base a y equals x, which means because logarithm is the inverse function of exponent, so when I write it in an exponent form, this is actually equals to a to the power of x equals y. We are talking about this a. In this case, rather than in logarithm, in exponent system, it would be much easier for you to understand. Let me take a value, any negative value for a, let's say minus 1 to the power of 3. In this case, a can be defined as negative number, obviously. But what if my power becomes fraction? That means minus 1 to the power of half, which is actually root of negative 1 that cannot be defined. It will not give you any real number. And that's the reason a cannot be lesser than 0. At the same time, it cannot be equals to 1. If I put a as 1 here, so 1 to the power of x, that means now I can pick any value for x. X can be 1, 2, negative 1, half, whatever you are selecting for x. My answer is always going to be 1. That means I will get infinitely many values for x. And if it's, that means log 1x is not a function. So because your a, when I put a as 1, it can give me infinite values, so it's not going to be a function, and this is the reason that a has to be greater than 0 or cannot be equals to 1. Now, this must be strictly positive. So you can easily understand by this one that whatever be the value, doesn't matter whatever be x is, if it's 0, if it's positive, if it's negative, if it's a fractional, you will always get the value y as positive, and that's why y should always be greater than 0. To understand this one, it says we cannot take the logarithm of a negative number, and again this can easily be explained by using the exponents. So same, let's say log ay is equals to x, which will give me a to the power of x is equals to y. I cannot take the log of 0. Log of 0, that means which number has to be 0? This number, because I'm taking log of this number, right? Log is with this. So that's why taking log means the number, if a log is attached with a number, that's basically it means we have taken the log of that number. I cannot take, or simply y cannot be equals to 0, because a to the power of x is equals to 0. Tell me any value for x that can give you 0. There's no value. Whether you take any very small, very big, positive, negative, or even the value of x you will take as 0, you will never get the value 0. And that's the reason that no matter how small the exponent is going to be, it will be close to, but will not give you exactly equals to 0. And that's why there is no real exponent that makes a positive base equals to 0, and hence we can say log base a0 is undefined. And that's the reason it says we cannot take logarithm of a negative number or a 0, because doesn't matter whatever be the value I'm gonna take, neither I will get a negative number or a 0. Moving on to the next one, this is a note, and we will consider this note while doing questions, which says while solving logarithm equation always check domain. So when I'll explain you the equation part, we'll consider this thing. Now to solve this, because ultimately our goal is to solve it in exams, so you should be aware of the laws of logarithm. So let me move on to laws of logarithm. First, product law. These laws actually simplifies a lot. It says log base a x plus log base a y is equals to log base a x y. That means that's what it's written. It simply says that there is any base, a can take any value apart from negative values, or you can say a has to be greater than 0 and cannot be 1, right? You have to keep in mind about it. So log base a, let's say x, plus log base a, let's say y, this can be written as log base a xy. Keep that in mind, your base should be same. If the bases are different, in that case you won't be able to apply this law. Example, log base 3 raised to 2 plus log base 3, here 5, can be easily multiplied together and will give me 10. So log base 3 raised 10 will be your answer. So this is how you can simplify this. Now next is quotient law. Here we subtract. Let me explain you. It's log base a x minus log base a y. Here it's given in terms of b, a whatever the variable you want to assign. Then it will become log base a x over y. Remember, 1 which is before the subtraction sign will become numerator. Take an example. Let's say log base 5 7 minus log base 5 3. So in that case I have to divide them. So that will be log base 5 raised 7 over 3. As I told you, the one which is before the subtraction sign will become the numerator, and that's how we can do. You can see this one, how easily we can simplify this one. So how we can simplify? Log base 5 125 minus log base 5 raised 5, This will become log base 5 raised 125 over 5, which is log base 5 25. And this can be further simplified, but that you can understand by the remaining laws. So moving on to the next one, which is known as power law. If you have log base b x to the power of n, x has power. So then this power will be shifted here. You can take it out and this can be simplified as n log base b raised x. This is a basic example I can say is log base 2 8 squared. So I have to bring 2 out and this will become 2 log base 2 raised 8. This is the way to simplify it. Further on, I can simplify 8 to 2 to the power of 3. So 2 log base 2, 2 to the power of 3. Again, I can bring this power out. This will become 6 log base 2 raised 2. And I'll show you how I can simplify this one. I'll be explaining you with the coming laws. Law 4 says the change of base law. If you want to change the base, you can actually swap it. So how we can do it? It's log base bx can be written as log base a. Generally, we convert it into log base 10. More specifically, you can say. But you can convert it into another base as well. So it would become log base a x this over this base. So it would be log base a b. And this is how you can change the base. And you can swap it as well. Which means if you have log base bx, this can be written as 1 over log x raised b. We can change the base as well by, if you want to swap the base and the number, you just need to reciprocal it. How? It was actually done through it. Say for example, if I want to divide it, if I reciprocal left hand side, log bx. So this would be reciprocal as log base a raised b, log base a x. And this can be converted into, again, log base x b is equals to 1 over log bx. And you can understand that this is basically reciprocal. You can do it. The same thing which I have explained you. Now, let me see an example. This one. So log base 4 8 can be written as, if we apply with a log base a equals 2 in this case, then this will become log base 2 8 over log base 2 4, because that will help us in simplifying it much better. So this can be written as log base 2 raised 2 to the power of 3 over log base 2 2 to the power of 2. Now bring it out. In third law we have seen, just bring it out. 3 will be outside and similarly 2 will be outside. And if you have the base number and argument, then answer would be just 1. So answer will become 3 by 2. Fifth law says identity law. If your base number and argument, they both are exactly the same, then your answer is always going to be 1. And also, doesn't matter whatever be your base, if number is 1, your answer is always going to be 0. So take an example of log base 70 raised 17. They have same number, so answer would be 1. And if it's 1 here, answer is going to be 0. So evaluating this would become much more easier, because this is 1, this is 0, answer is just 1. So these are basically all the laws of logarithm. In our next class, we'll be covering the next theory of log. And before I go, if you need my Patreon link, You can just comment TMUA and I'll post it. You can access all the hot questions on TMUA. The subscription is pretty much affordable. You can take free lessons here, but the paid lessons on Patreon. And also, if you need live online classes with me, you can register for free trial. So that's it for today. Bye everyone. Take care.